Welcome students. So we move to the next concept. Okay. So before this, the concept which I'm bringing you all today, there are two things which needs to be done. Okay, which we will do once we complete with these two algorithms. That's Deffie Hellman key exchange and Algorithmic public key crypto system. So we need to learn what is discrete logarithm and solve how to use this discrete logarithm to solve Deffie Hellman algorithm. So let us start with today's class. So today's class we are going to learn Deffie Hellman key exchange algorithm. So this algorithm is basically used for exchange of keys, okay, between the sender and the receiver. Okay, so between the sender and the receiver, you need to exchange a key or generate a key which will be common to both of them. Okay, so to generate that key, we require something which is called as Deffie Hellman key exchange. Okay, now what happens in Deffie Hellman key exchange is each of the side. Okay, now for example, A wants to send the data to B. Okay, A will have its own private key, B will have its own private key. Okay, so they are not going to share their private key because it is private to both of them. Okay, so A will have its own private key, B will have its own private key. But the public key which is present with A will be shareable with B. Okay, and the public key which is present with B will be shareable with A. Okay, so now for example, if so what will happen over here, I can just show you all with the help of a diagram. So there is a sender A, okay, and there is a sender B. Okay, so he will have its own private key, he will have its own public key. Okay, so this person will always have his private key and public key. Okay, will have public key. So this private key will be always secret. This won't be shared in between each other. But this public key will be public to both. So this public key will be easily visible to this, and public key of B will be easily visible to A. Okay. So what they will do is, to compute the key. Okay. Now to A to compute the key, it will take the help of private key of B. Okay. Sorry, public key of B, and private key of itself. Okay, so calculate the key, and similarly to calculate the key over here, the similar key over here, B will do what? Okay, he will use its own public key. Okay, it will use its own private key. Okay, so private key, it will use its own private key. Okay, and public key of A. Okay, and public key of A. So they are exchanging the public key, but the private key remains the same. So that is what we are going to learn today in Deffie Hellman key exchange algorithm. So let us go to step number 1, okay, of this algorithm. So step number, it's a very simple algorithm. You just have to keep the formulas in mind. So because of which I have taken this topic before we go to discrete logarithm and Deffie Hellman algorithm. Okay, so step number 1 is your user A. A is nothing but the person who user A is a person who is sending or receiving, or similarly user B is a person who is sending and receiving. Right now we don't know who is sending, who is receiving, because right now we are just generating the key. Okay, we are just generating the same key on both the sides, okay, so that they can use the key. Now user A selects a random integer XA. So XA is a random integer selected by user, okay, so which will be less than Q. Q will be a large prime number that will be provided to you. XA will also be provided to you. So XA will chosen by A. XA is the number which is chosen privately by A. So XA becomes the private key of A. Okay, and it will compute what is YA. Now YA is nothing but the public key. So XA is the private key which is generated, is a random number chosen by A, and will generate what is the public key. How is going to generate the public key? Alpha raised to XA. XA is the number that he has chosen privately. Alpha raised to XA mod Q. Q is provided to you. Alpha will also be provided to you. Okay, so how alpha is generated, Q is generated, we are not interested in that because the values are already provided to you. So using his private key XA, he is going to generate a public key. Okay, similarly user B will also take its private key as XB, okay, which is less than Q, okay, definitely less than Q, and he will generate its own public key. Okay, the public key will be what? YB. That is nothing but alpha to XB mod of Q. This XB is what? This XB is nothing but your private key. Okay, this is nothing but a private key of your B. So always keep in mind, your XA and XB will be private key of user A and user B. Okay, and YA and YB will be your public key of user A and user B. Okay, so in step number 3 what I have written is, so each of them, so each side means nothing but A and B, okay, will keep the value of X as private, as I have told you, because XA and YA both are, XA and XB are both private values of A and B. So they will keep the X value as private and they will make Y value publicly available to the other side. Okay, so the x value will be private and y value will be public. So x value will be private, y value will be public. So that public value values are known. Now for example, public key of A is known to public key of B. Sorry, public key of A is known to B and public key of B is known to A. So they are public. Okay, in general they are public in nature. So that is what I have written. XA is A's private key, okay, and YA is A's public key. Similarly, anything in X will be XB is B's private key and YB will be B's public key. So now how do I compute the key? Now user A will compute the key. Very simple formula. User A, to compute the key, as I have shown you in the diagram, what he will use? He will use his own private key and public key of B. Okay, so to generate a key, so he will use his own private public key, that is YB, as I have written over here. YB, so public key, he's not his own public key. He will use the public key of user B. Okay, so don't get confused over here. So while explaining, I'm also getting confused. So don't get confused. So what we will do is, when A wants to create a key, he will use public key of B because he cannot use private key of B. Correct? He cannot use private key because it is hidden with B. So he will use public key of B and his own private key, that is nothing but XA, mod of Q. Okay. Similarly, when B wants to compute the key, what it will do? It will be exactly opposite. He will use the public key of A and its own private key. So YA raised to XB, mod of Q. We will compare both these keys. If both this key match, that means you have done the problem properly. Okay, you have solved the problem properly, and that will be the key that will be used on both the sides for encryption as well as decryption. Okay, so this is our Deffie Hellman key exchange algorithm. We will solve a small problem. So usually all these values will be provided to you. Okay, usually all these values will be provided to you. That is, alpha value is provided, Q is nothing but a prime number. Okay, XA is the private key of A and XB is the private key of B. Okay, so let us start. So in step number 1, what we need to do? So in step number 1, what do we need to do is nothing but we need to calculate what is YA. That is public key of A. So YA is nothing but, as per the formula, alpha raised to, so we will just replicate this formula. Alpha raised to XA. What is alpha? 7. 7 raised to 3. Okay, 7 raised to 3. Okay, mod of Q. Okay, 7 raised to 3 mod of alpha raised to XA mod of Q. Q is nothing but 11. Okay, so we need to find out what is 7 raised to 3 mod of 11. Okay, so let us find out what is 7 raised to 3 mod of 11. Okay, so when we solve this equation, 7 raised to 3 is nothing but 343 mod of 11, we get answer as 2. Okay, so we have calculated the public key of A. Okay, similarly, now in step number 2, okay, so this is my step number 1, so let me write down step number 1. So what I will do in step number 2, in my step number 2, I am going to calculate what is my YB. So exactly this step I am going to replicate, that is the public key of B. So YB is nothing but alpha raised to XB. What is alpha raised to XB? Alpha value will remain as it is. XB is nothing but 7 raised to 6. 7 raised to 6 mod of Q. Okay, mod of Q is nothing but mod of 11. So let us solve what is 7 raised to 6 mod of 11. Okay, so when we solve 7 raised to 6, we get the answer as 117649 mod of 11, which is nothing but 4. So now you know what is my public key and what is my private key. So in step number 3, I will just write down, okay, I will just write down my XA, which is nothing but the private key of A, and my YA, which is nothing but the public key of A. So XA is nothing but which is given to us 3, okay, and YA is nothing but that we have calculated, that is nothing but 2. Similarly, we will calculate what is XB, okay, XB is the private key of B. Okay, XB is the private key of B. Private key of B we have already taken, it is given to us as 6, and the public key of YB, okay, public key of B that is given to us is nothing but that we have calculated is nothing but this 4 value. Okay, so this is your private key and public key. So we have written step number 3. Now step number 4 is what? Step number 4 is I need to calculate now the user A, calculate the key. Okay, so how to calculate the key for user A? We will just replicate this formula over here, calculate the user A. Key is nothing but YB. So what is the YB? YB value is given to us. We will directly take this value 4. Okay, YB is to XA. What is XA? XA is nothing but 3. So YB is the public key of B. See, there is a public key of B, and XA is the private key of A. 4 raised to 3 mod of Q. Mod of Q is taken as 11. Okay, so mod of Q is taken as 11. So when we solve 4 raised to 3, okay, 64 mod of 11. So what is 64 mod of 11? 64 mod of 11, when we calculate, we get the answer as, so we get the answer as 9. Okay, so we get the answer as 9. So now step 4, already A has found out the key. So in step 5, what we need to do now, we need to check the key which is computed by B. So to compute the K, so it will use K equal YA. What is YA? YA is the public key of A now. So when B is computing, it is using public key of A, okay, raised to XB. What is XB that is given to us? What is XB that is given to us is nothing but 6, okay. So this is the value of XB that is given to us, mod of 11, okay. So let me check what is 2 raised to 6 mod of 11. So again it is 64, okay, 64 mod of 11, okay. We have already calculated what 64 mod of 11 is nothing but 9. So both the keys which are calculated by user A and B are 9. That means proper keys are generated. Okay, proper keys are generated. Okay, proper keys are generated and exchanged. Okay, proper keys are generated and exchanged. So this Deffie Hellman key exchange algorithm is basically used for exchanging, generation and exchanging of keys, okay, where you just need to keep the formulas in mind. What is YA, what is YB, okay, what is XA and what is XB. So X is always a private key, XA is a private key of A, XB is the private key of B, and Y is the public key of A, YB is the public key of B. So using this you need to solve a Deffie Hellman key exchange algorithm. So I will give you more 3 examples to solve, okay, for Deffie Hellman key exchange algorithm, okay, in your tutorial. So that's all for this session. In the next session we are going to learn Elgamal public key crypto system. One more algorithm which is used in crypto system, Elgamal public key crypto system. Thank you. That's all.